very good insight to the problem. That means QP star is, so according to my understanding, what will happen is these powers will not change, these coefficients will change in case of the real life dam breach. Okay, let us go to the next. Similarly, this is a spatial breach. You remember in the beginning I showed you two figures. One was on the bottom, so it was a spatial breach in which you see the figure which is below in B. So we create a pilot channel. We call it a pilot channel. This is built purposefully on the top of the dam. Why? So that water is guided only to pass through this opening. And if you see the papers, there are several research papers on this. So they select this pilot channel randomly, meaning whether it will be triangular or rectangular, or if triangular, what size, if rectangular, what size, why not parabolic, why not circular? All those questions are there. So in this paper, we tried to conduct a study in which we studied what are the different shapes and sizes of the pilot channel, so that the final results will not change, because your final results should not be dependent on the pilot channel shape and size. If that is the case, then it has to be appropriately chosen. Okay, let's go. So you can see this is again from the literature. This was a 2004 paper, experimental paper by Chidarasri et al. And we conducted the simulations for the same experiments using Flow 3D. As compared to the other bridge, planar bridge, there we could establish a very good match between the experiment and the numerical. Here, we are not so successful. For example, you can see figure number C. The dots are the experimental things and the solid lines are the numerical thing. So there is a quite mismatch between the two. But what we have done is, while doing this, because we have the freedom to choose the numerical parameters. So what we did is, we selected the parameters such that the breach volume is same. From the experiment, whatever is the volume of eroded materials, it is same in the numerical. So that way you can also see this way, the area under the dots and the area under the solid line, they are made equal. In that sense, we matched. Okay, let us go to the next. Again, let us assume some good luck persists. So can you please check? There will be some triangle and you can just click it. Yes, please click this. Yes, click this. Something is happening. Please wait. So maybe it is, no. Once again, please click that triangle. Yes, if something is happening. QuickTime not available. Oh, in your computer there is no QuickTime, therefore it is not running. Okay, we got it. We'll see that later. We can probably play it if QuickTime is available. So please go down. Yes. So we could identify based on our simulations that there are different phases. We identified 3 phases. In the literature, you will find different researchers, they could recognize different phases, but according to us, we identified 3 phases. Phase 1, which we call as breach initiation. Here overtopping starts, small erosion on downstream phase, pilot channel starts widening, downstream slope starts retrograding. Then in phase 2, we call it breach evolution, the downstream slope to upstream dam crest. That slope comes to upstream. The slope is eroded, downstream phase is eroded, and that erosion comes towards upstream phase. Slow widening of pilot channel, depth of pilot channel increases, height of dam remains constant. Remember that in this phase, the height is still the same. Okay, and in third phase, please go to the next. In third phase, it is a rapid widening of breach, height of dam decreases, breaching becomes, and all these things. Please note here that in levee breach or dam breach I am not very sure, but in levee breach, what is done is, I'll tell you what was done in India and what was done in US. In US, there was something called Hurricane Katrina. It occurred in 2005. So one levee broke. It is similar to this kind of a thing. Okay. So the engineers came in helicopter. They put some stones on the levee wherever it was broken. On top of that, they just threw those stones. They dropped the stones, heavy stones from the helicopter. And that way they tried to close the bridge. Please note that if we are in phase 1 or in phase 2, probably we can control the bridge. We can try to close the bridge. But if we are in phase 3, it is very difficult. It is very difficult to repair. We cannot contact. Okay. In that sense, identifying these phases are important. Okay, let us go to the next. So, as I said earlier, what we did is we tried different shapes, for example, triangular or rectangular or parabolic, circular, different shapes and different sizes. For example, in triangular, you can mark the depth. The depth is 1.5 to 2.53. And the top width varies from 6, 7.5, 4. So we use different shapes and sizes of these pilot channels to know what is happening at the end. Okay. And similarly for the rectangular channel, different shapes, sizes. Please go to the next. So in this presentation, I am not showing the other shapes. I am showing only triangular and rectangular. But we conducted for parabolic shape, for circular shape. So we took special care to have, because the first thing is fitting the geometry in Flow 3D. So creating the geometry for those special cases was, we took extra care to prepare those shapes using the geometry. So let us see some results. This is the effect of depth on bridge shape. You can see these are 3 different depths, 1.5, 2 and 2.5. With time, how it propagates. You can see a lot of difference between the first 2 sets of lines. But in the third set, it was almost same. All the 3 shapes, their eventual results were same. Okay. But in the first two things, it was different. So let us go to some other results next. Similarly, here it is rectangular. The earlier result was for triangular. This is for rectangular with different depths, 2 centimeter and 1.5 centimeter. And then we saw that initially, to start with the simulation, initially up to certain times, there was some effect, but towards the end, the end results are same. Okay, please go to the next thing. Similarly, this is effect of depth on bridge, and one is rectangular. You can see this. This is from another side. Okay, the other picture was showing what is happening to the. So these are for the same results, but looking from different sides. So you can see how the pilot channel increases here. For example, it started with a triangular thing, and all these 3 things, they indicate the 3 depths, but with time, the pilot channel increases. But if you see the last set of lines, 4 lines, then all of them, usually they merge. So again, the same story which was depicted in the previous figure, the same story is here. And the below figure is for the rectangular thing. Once again, if you see the last set of lines, those are same. That means whatever shape and size you take, eventually the end result will be same. But note what I said in the beginning, phase 1 and phase 2 are not less important. Phase 1 and phase 2, they are equally important. In fact, they are more important, because this is something like the man is dead and you are doing some post-mortem. So last line, although it is important, but first 2 lines are also important because they are related to the first 2 phases. So if we can, because the shape and size influences the first two phases, that means we can better prepare for our engineering of closure of breach in a better way. That means in the research, what we found out, I will show some more results, but let me tell you the summary of this exercise. The summary is that we have used different shapes. Again, in the same shape, we have used different sizes, but we found out that triangular shape with some kind of smoothening on its bottom is the best shape. And when we say triangular, of what depth or what top width, it should be such that the water is able to come to the other side. So it should be as small as possible. Please note that if you are in numerical, it will run always. But if you are conducting experiment, we have also conducted many experiments in this. If you are conducting experiments, then if your pilot channel is of very small size, then it will, the water from the reservoir will start going to the other side, but after 5-10 seconds it will stop. Okay, because there will be, in all probability, you will prepare the dam with sand and other things, so they will soak the water, and eventually there will be no water from the reservoir to the other side. So there is a minimum size and shape required for the water from the reservoir to go to the other side. Okay, let us go forward. So these are some other results from the same test. What I said is we tested different shapes and sizes. For example, this is the effect of top width. Now, keeping the depth same, if we change the top width, what will happen to the breach? Okay, next. Similarly, this is effect of top width, but the vision, the figure is projected from a different angle, so that we can know what is happening to the pilot channel, how the pilot channel is increasing. Here it tells a very interesting story. You can see that eventually where we got this conclusion from these figures, that you can see, although we tried with a triangular or a rectangular, so comparing both, whether it is triangular or rectangular, eventually the propagation is going to, the evolution is going towards a triangular shape with a smooth bottom. So why not from the very beginning you choose that shape? That was the logic. Okay, please go next. Again, this is effect of area. Please go next. So the purpose was, suppose I have a triangular shape and I have a rectangular shape, and suppose the area, the projected area of both the shapes are same. What is the effect? Is area is a factor? We found no, area is not the thing. This is similarly effect of area on breach shape. Okay, this is breach, not beach. Okay, please go to the next slide. These are similarly, please go ahead. This is again on the erosion rate. Erosion rate means in not in hydraulics, but for geotechnical point of view, erosion rate is a very important parameter. So it all depends on how you compact your earthen dam and what is the properties of the material that are used in the dam. So in order to know that, what is the erosion rate? Now, this erosion rate will depend on compaction is there, soil material is there with its properties, but the flow will decide what will be the erosion rate. So, in respect to that, depending on the flow, what is the erosion rate? So, one can find with time how is the erosion rate. So, initially it started with a slow erosion rate, but then the erosion is very high, and then eventually there was no erosion. And it is at par with the discharge. When the erosion rate is very high, the discharge will be very high. And eventually in the beginning it will be less, and at the end it will be less. But in between it will attain its peak. Please go to the next. Effect of top width on erosion rate. This is triangular and rectangular. Please go to the next. This is again effect of area on erosion rate. And yes, please go to the next. This is effect of SAPE on erosion rate. As I said, I am showing here only two, but it would have been more interesting to see things. Let us go to the next slide. This is again a breach volume. These two are not similar or same thing. Erosion rate may be okay, but breach volume is what is the amount or what is in meter cube the volume of the eroded material. So we measured that, I mean, from the numerical exercise. We conducted experiments, as I said, but these results are exclusively from the simulation from Flow3D. So the results will give you the cross section and you do a little bit of trick and you can calculate what is the volume, what is the eroded volume. So that way we could find out the eroded volume. With time it increases as expected. So please go to the next. Again, go to the next. These are all similar things, but showing different parameters and its effect on different things, like what is the effect on discharge, what is the effect on breach shape, evolution of breach shape, or what is the effect on breach volume or erosion rate, that kind of a thing. Please go to the next. So this is interesting. You can see the breach discharge. To make my point, you can see this is a hydrograph. Hydrograph means the discharge through the breach. So you can see there is a peak getting attained here. Okay. So it started with very small discharge. It attains a peak. Okay. And then it again decreases. So to capture this peak is crucial because this is the design parameter. We don't use in design all the information from this curve. We use only the peak value. Okay, next. Yes, we'll go to the next. Same thing. These are discharges again for different shapes, sizes, and different cases. So these are some of the conclusions. Please wait. This is I indicated some 3D simulations using Flow3D. I have not mentioned here Flow3D, but Flow3D is crucial to this work, and I should always give credit to Flow3D. I myself, I have developed some programs not as good as Flow3D, but I have my own programs. Those can be used for small problems. And I showed some planar breach and spatial breach. This is good. Flow3D is good. Please note that this Saint-Venant equation or Hay-Crash, using Hay-Crash, you cannot study these kind of phenomena. Simulations match with experiments. Phases of dam breach identified. Peak breach discharge was found out. Peak erosion rate was found out. When I said the last two lines, we found out some non-dimensional equations based on our simulations for these two parameters. So these two, the last two lines are our contribution from this study. So I have some more slides, but I do not know whether we can see it or not. Please go up. Come down. Okay. Thankfully, it is running. So to have some fun, I am indicating here some simulations from Hay-Crash. This is using real life dam break flow analysis. When I said real life dam break flow analysis, the river is real, the dam is real, but its breach size is hypothetical, and the flood, it never happened. Please don't be under the impression that there was a dam break and this was the actual inundation. It was not that. If the dam breaks, this would be the inundation. That was the story. And also I would like to mention here that I said so far that Flow3D is good in one sense and Hay-Crash could not do this. But if you see this, Flow3D cannot do this. So I am trying to project the contrast. So depending on your purpose, okay, you can select the model and use the model and get some results. So because, as I said, I am working something in Narmada River. This Ministry of Jal Shakti has given me a very 10 years project, very high budgeted project, and different aspects of Narmada River we are studying. So one of my students did this in Hay-Crash. Please go to the next, maybe. So Narmada River has many dams, but I have selected 4 dams. Those two are for two dams. You can see the names. For example, these two, one is Indira Sagar, another is Sardar Sarovar. Thanks. If you have some questions, feel free to ask me. I am supposed to be nobody should praise himself or herself, because in our scriptures they say if you praise yourself, it is like a crime equivalent to suicide. But having said that, let me also tell that I am supposed to be the best person in dam break flow in our country. So I am pretty confident to answer some of your questions if there are any.
Yes, my dear participants, if you have any question, you can ask.
Okay. Since there are no questions, I thank NIT Patna for giving me this opportunity to deliver this lecture. And I am very happy that I could, in spite of those technical glitches, the lecture was over. I am very happy about this. Thank you.
Thank you, sir, for your time. Thank you very much, sir. And sir, you may join to our validity session also, because we'll soon close this by 12:30. So
Okay.
validity session will start from 12.
So
With
the
the
same link.
Yes, same link.
So I'll join at 12:30 then.
Okay, sir. It will start from 12, then it will end at 12:30.
Oh, okay. So I'll join at 12.
Okay,
This
sir.
is 11:40. So I'll join at 12.
Okay, sir. Okay, sir.
Thank you very much.
Thank you, sir. Thank you.